today's class I am going to discuss about the subject is microcontroller 8051. In that, the module 3 is going to discuss about the stack and what is the stack operation and what are the subroutines meaning. Okay, and these all we are going to take in this particular class. Okay, so we start with what is a stack. Okay, so basically the stack is a part of the internal RAM, or it is RAM. Okay, you can call it as a RAM. So RAM is a random access memory. So that I have shown you what is the 8051 RAM is having here. So those the part of that I have shown here. Okay, and basically your internal RAM is going to start from 002 FFH. Okay, because this is a 256 bytes of RAM you have as an internal, and it can extend up to 64 kilobytes. Okay, and then what is the register which is helping you to access this particular stack is stack pointer. Okay, and this register is of 8-bit, and it is again ranging from 00 to FF. You can mention the stack within this range from 00 to FF, because the stack pointer can hold 8-bit of data. Okay, either it is from 00 to FF, any address you can mention. Okay, and the next is which are the instructions are helping you to load the data into the stack and unload the data from the stack. Okay, those are push and pop operations, pop instructions. Okay, and these instructions we call it like a call instructions. Okay, so this we call it as a call instructions also. Okay, and what is the push operation does? Okay, what is the push meaning is, so we are going to push the data into the stack, okay, or load the data into the stack, okay, with the push instruction. Okay, what is the pop instruction? We are going to take from the stack, okay, with the help of pop, or unloading the data from the stack with the help of pop instruction. We'll see this push and pop operations with the help of one example. Okay, so basically I told you your stack pointer is going to be point at 07H of your internal RAM. Okay, by default, or it is at power up condition or in reset condition. Okay, your 07H. Okay, you are pointing, the stack pointer is going to point at 07H by default it is. Okay, so there is no restriction like you have to start from the 07 itself. In the program, when you are writing the program, you can change the address. Okay, where actually your stack is going to be begin. Okay, that you can change it, and that should be within a 00 to FF again. Okay, so here in this example I have taken the move SP, that is stack pointer, is loaded with 07H. Okay, so if your the stack is going to start from 07H itself, then no need to mention it. Okay, if this instruction is not there also, it is going to take your stack pointer as a 07 itself. If it is apart from the 07, okay, if suppose you are going to start the stack pointer from the 0A, then it is mandatory to mention it. Okay, it is mandatory to mention it. If the stack pointer is going to start from 0A, then your stack pointer is going to point at this particular point. The stack pointer is going to point at this particular point. So then this will go off. Okay, this is the default value of the stack pointer, and from the program I can change the start of the stack. Okay, start of the stack. Then, so if I change this to 0A, the stack pointer is pointing at 0AH. Then what happens is, with the help of first instruction, push 00H. So what it does, it takes the data from 00H. So where is your 00H in your internal RAM? So here it is. Okay, and 00H is having 83H as the data. Okay, as a data. So this particular data I am going to take it and push it to stack. So what it does, it takes the data and push it to the stack. Okay, before pushing into the stack, there is the one operation is must, that is, so whenever push instruction, whenever 8051 listen to push, what it does, it is going to increment your stack pointer by one position. So your stack pointer is pointing at 0BH. Okay, then it will load the data. What data? 83H is the data that I am going to load it into this particular location. push on again whenever 8051 listen to the push instruction or see the push instruction, what it does. So again it is going to increment your stack pointer by one more position. Okay, so what is that position is 0CH and take the data from this location, that is 01H. What is the data which is there in the present in 01H is 75. Okay, take this data and load it in this particular location. So it is 75. Okay, 75H. I have loaded. Okay, so this is your stack. Okay, this is a portion of the stack. This is a portion of the stack. Okay, so next, what is the next instruction is pop. Whenever again 8051 will listen to the pop instruction, what it does? First it takes the data into the mentioned address, then it will decrement the stack pointer by one position. Okay, so what it does? Whenever pop appears, it is going to take the data out, that is 75 is going to come out and load it in 01H. Load it in 01H. So it will be loading back to 01H. That is 75. Okay. Then it is going to decrement the stack pointer by one position. Decrement the stack pointer by one position. Okay. So here is the stack pointer now. So here is the stack pointer now. Now again, one more pop instruction is there. Whenever again pop instruction appears, again what you are going to do? You are going to take out the data from the pointed stack pointer. Okay. And take the data and where you have to load it. You have to load it in 00H. So take the data and load it in 00H. What is the next operation is? So you have to decrement the stack pointer by one position. So right now it is there in this particular location. So 2 times you are going to push it and 2 times you are going to pop is nothing but you are going to come back to the same position of your earlier. Okay, so it is equally you are pushing the values and equally you are popping out the values. So I am going to come into the same address of the earlier. Same address of the earlier. See, I told you the call instruction, this push and pop instructions are also called as the call instructions because so whenever the call appears in your main program, okay, in your main program, what happens? It's going to divert from your main program to the subroutine program, okay, then execute the subroutine program and you are going to have the return over there. So whenever return appears, it is going to come back to the main program. So this particular operation is also done with the help of push and pop operations, that is utilization of stack is going to happen here. Okay, so what happens if I take one more example with the help of call and return instruction, we will see how this push is going to, push and pop are going to be helping. Okay, so look at here. In the second example, I am going to start with the ORG 000. Okay, so I am going to start from the 000H of your ROM. Okay, you are going to load the instructions. Okay, I am going to jump to 30H because in the, from 0000 to 0030 some interrupt programs are going to be load. This interrupt address are going to be ISP address are going to be load. For that reason, I am going to jump it by 30 and I am going to fix my origin as 30H. Okay, then I am going to start. Okay, so actually, what is the address of this instruction is 0030H because it is going to start from 0030H. Okay, so suppose then this in first instruction, what I am doing, I am just written one example over here. I want to toggle the data which is present in accumulator. Okay, which is there in accumulator. First initially I am going to load the accumulator with 00. Then after some delay I am going to toggle all the bits of accumulator, okay, by loading it as a FF. So then again I am going to call a delay for sometimes I am going to leave it. Again I am going back to the start so that it can load again 00. So this is loading one time 00, the other time is FF. That is nothing but it is going to have the all zeros in accumulator. After some delay, it is going to have the all ones in the accumulator. See, it is toggling continuously. So this is your main program. Okay. So this entire is your main program. This is entirely your main program till this. Okay, till this it is the main program, and this is your subroutine program. This is your subroutine program. So look at here. First I will load my data, that is 00h, into the accumulator. Then I will call a delay. So whenever I call a delay, I'll be loading the address of the next instruction. So this address of this, that is, suppose it is a 0034h. Okay. Suppose the address of this instruction is 0034. Okay. So whenever you are going to divert from main program to the subroutine program, okay, so you need to store your next instruction address into the stack. Okay. How to do it? How to do it is, so you are not going to do this, it automatically does, because it is a call instructions are there. Okay. So this lower byte will be what is the DPL, the address of the DPL, and this is the address of the DPH. So automatically this DPL value is going settled in the stack. Okay. So in our case we have already stack is defined as 08. Or else for this example I am not mentioned any stack pointer. Okay. Changes. Okay. So what it does, by default you are going to, your stack is at 07h. Okay. So whenever it happens, no, you are going to take your DPL data first and store it in a stack. So it is going to be stored in the stack. So before storing it, it has to increment by one position, and it is going to store in this particular location. So then your number will be stored as 34h. Okay. Your DPL is going to store it in the stack initially. Then it is going to take the DPH value and store it in the next location by incrementing the stack pointer by one more position, and store the data into the stack. So in this particular you are going to store the 00h. So you are going to temporarily store the address of the next instruction, okay, in the stack area with the help of push operations. Okay, this happens whenever the ACALL is read by the microcontroller. Okay, it does automatically. Then, so whenever ACALL comes, this is going to happen. The pushing of the address of the next instruction is going to happen. Then after that, what it does is, it is diverted to subroutine program. It will get diverted into subroutine program. So what happens in subroutine program? It is simply generating the delay. Okay. So here we are going to load FFH into the R0 and keep on decrementing the R0. Okay. For every time it is going to decrement by one position from FF to FE, FD, like that. It is going to till where, so when R0 is become equivalent to 0. Okay. If it is not 0, I am going to keep in the same loop. Okay. So when your R0 becomes 0, 0, then I am going to go for the next instruction, that is a return. Okay, what is the return instruction does is, again the return instruction, whenever return comes, it is going to get into the stack and get back the address, because you should know, no? So from the subroutine program, when I am diverting back to the main program, where to go it? Okay, where to go it? So for that reason, you are going to return, whenever return is heard from by the 8051, it will go back to the stack and retrieve this data. What is this data is? That is 00. That is DPH. Okay, this will be again loading into the DPH again. Okay, and decrement the, so again 2 pop operations you require. Okay, internally, and decrement the stack pointer by one position. Then this data, it is going to be loaded into the DPL. Okay, so here is a DPL and here is a DPH. Okay, so you are going to get back your address which is stored in the stack, that is 0034. Okay, then when it comes to this particular position, you are going to change your data which is there in an accumulator by FF. That is, all the bits of accumulator becomes high. That is 1. So it is toggled from 0 to 1. Again, you are going to call a delay.